So with all that being said, we're going to talk about working directories next. So like I mentioned, you could maybe set your working directory to be a desktop folder for most of the time that you're working, or you can kind of change it every time when you're starting a code. And basically a working directory is a folder that R is like pointing to at the time. So if you set the working directory, anything that you're trying to open can come out of there, and anything that you save will go into that folder. So there's two ways to set it as usual. You can just type it directly in, set working directory, and then put the whole file path in here. Or you can use the window in the bottom right. You would open up your Files tab and then go down to this drop down and set your working directory. And so once you've done that, you can go ahead and import files. And there's several different types of files that R can read. You may have heard of CSVs before, which stands for comma separated variables. And you can generate these from Excel spreadsheets. You can save Excel as save as CSV. And then you can go ahead and open them in R later. Or you can actually directly open Excel spreadsheets in R. That's a little bit more complicated because you have to install a specific package to do it, but it is possible. So if you have all of your data already in an Excel sheet and you want to import it to R, it's definitely possible to do. You can also import text files. So you would just use this function read table. And a little note here too, you see that header equals true function in there. That's basically telling R that you have column labels above your data. So that'll tell it that first row is not a row of data, that's actually header names. And then finally, you can use R data files. And I work with these a lot because you can create them in R, and that can save single or multiple objects. As Tim was saying earlier, objects are those little basically packets of data that you are named, and you can change the names and you can save them in R data files like this. You can also save variables and functions and other types of data in an R data file. So very useful to be able to use these. And as I mentioned before, you could set a working directory and then you're saving and importing everything from that file, but maybe you're trying to get data from different folders across your computer. So you can actually copy the entire file path in when you're trying to, say, open a R data file. You can actually go and copy the entire file path. And on Macs, you can open up or change this little option on the Finder windows so that you have the whole file path at the bottom. And then you would just right click on the file at the bottom and copy as the path name, and it'll pop up that you can paste into R. So this is, again, this is a function I've used a ton of times. Very useful to know. And so we've been using a lot of vocabulary, which I want to kind of explain here more too. We keep talking about objects. So R is object-based. You would save them in these named pieces of data, and you can create them using the equal sign or the little arrow. I tend to use the equal sign just because that's how I learned it at first, but you can definitely use the little arrow as well. And the thing to remember with that is that you have your object, and then the data is pointing to the object. So you're basically pushing the data into the object. So you want your arrow pointing to the left towards your the object name that you're making. And so this is just a quick little example. You can basically name it anything. It can include numbers in the object name as well, but that can't be the first character. You always have to start with a letter as the first character. And you can add underscores, but no spaces. And there are a few different character types or data types that R recognizes, and it's important to kind of know which one you're working with at the time. Because, for example, if you try to put a character vector into a function where it's expecting numeric, it won't actually be able to carry out a math operation on it. So characters are, for example, words, or you could force a date to be a character vector. It's just saved as generally like a word. And then there's numeric, numbers, very intuitive. You have integers, which are just numbers without a decimal afterward. You can have logical data, which is basically true, false. You can have factors, which is a categorical variable. And So if you don't know which one you're working with, say you import an object from an Excel sheet or our data, and you don't know what type of object it is and it's screwing up your functions, you can investigate it using these other functions. So you can type in class and put your object here in the middle of the parentheses, and then it'll spit out, for example, it's a character vector, and maybe you want it to be a numeric, so you can change that later. So these are very helpful as well. And you could do structure, which will give you the dimensions of the object and what type it is. You can do length, which is basically how many items are in this vector. And yeah, and so on and so forth. So again, we'll give you this PowerPoint. So if you ever get stuck, you can go back to these and try and figure out what does my data look like. And I keep talking about vectors, so I should explain what vectors are. They're basically a single list of data, which you can think of as a single Excel column. And so it's just one dimensional. And you can make vectors. If you have some data and you want to force it into a vector shape, you would just use this as vector function. And then you can find out how long it is by using the length function. Then we have some two-dimensional data. So we have matrices and data frames. These are both two-dimensional. They have rows and columns. And they're really, the difference is you just want to make sure which one you're using, because some functions will only work on matrices and some will only work on data frames. So they're quite similar, but you want to know which one your data is so that it will actually work with your functions. The other little difference is that data frames can have row names as well as column names, where matrices just have column names. And as always, if you're stuck on which one you need to use, you can always use the help function on the function that you're trying to use, and it'll tell you if you need to work with a matrix or a data frame, for example.
So once you've kind of made those different vectors or matrices, there's a lot of different ways you can work with that and manipulate those. One of the big ways you can do that is with something called indexing. And that involves those square brackets. So you can use those square brackets, and if you put a number in there, or two numbers, depending on if you have a vector or a matrix, you can actually call that certain position in the vector. So if you had vector square brackets 1, it would print out the first object in that vector. Or if you did a matrix 1, 1, you would get the first item in the first column in the first row, in that kind of indexing way. So if you have like a data frame, you import it as a CSV and you realize later you typed in the wrong number or something's wrong, you can go in and replace those. You can also combine vectors with data frames, or you can combine two vectors together, or even append a single number to the end of a vector with the combine or concatenate, so that lowercase c. So you can just combine two things, the first thing, comma, your second thing, and put those together. For two-dimensional things like matrices or data frames, you can actually add columns or add rows with cbind and rbind. So cbind will add a column to the end of your data frame. Rbind will add a new row to the bottom of your data frame. And these can be super helpful. I use this a lot when I have like similar data frames that I want to put together into a giant data frame. So I'll like just rbind multiple objects together. Just like you can add stuff, you can remove it as well. So you can, in the example here, you can select which rows you want to keep. So we want to keep columns 1, 2, 3, and 4. That's what we mean when we do 1:4, 1 through 4 of that matrix. So you can select the first 4. This way you can also do, if you just wanted to delete the 5th column, another way to do this would be to write in that square bracket, you would do comma -5. So kind of like we said before, there's a lot of different ways to do things. So just do whatever makes you comfortable and what makes the most sense to you. Like we said, some things matrices and data frames can have column names. So if you import, again, a CSV of your data and the column names for whatever reason didn't come through, you can always add those back in manually through the colnames function. And you would just give it a list of character strings and quotations that you want your columns to be named. One problem I have often when I do this is I accidentally add one extra column, or I miscount the number of names I need to add, and you'll get an error. So make sure you have the right number of names in there. And then finally, if you have two data sets and you want to multiply like one vector by another, you can do matrix math really easily. As long as they have the same dimensions. If they have different dimensions, it'll get weird. But what happens is if you have two vectors, it'll multiply the first item in your first vector by the first item in your second vector. So it'll go line by line and match up the dimensions and do that math for you. You can also do means, medians, modes, all those kind of math functions on single columns of data, multiple columns of data, things like that. So we've talked a lot about what objects, all the data you can have, how you can mess with it. Now, Tim and I are going to talk to you about two different ways of plotting. There's base and there's ggplot. I like base. I think it's better than ggplot. Tim will fight me and thinks ggplot's better than base. And so everyone has opinions on this, and we're going to show you a few different ways to work with both of these. The reason I like base so much is because I think it's really really customizable. It's also the default plotting system in R, so you don't have to go through installing another package. It's really easy to customize figures. They follow a simple XY format, so you can plot X comma Y, or you can do what I do and write Y as a function of X. That's what that little squiggly line means. But both of them will produce the same plot. So again, just do whatever you're more comfortable with. A lot of plots in base R can be made with a single line of code, which is really nice. The example I've shown here is something that I'm working on with my own work. I made this with a single line of code. Everything from resizing the points to generating the line to making the axes legends was all done in one line of code. You can make plots a little bit more complicated. You can make maps, kind of like that one. So this involved a few more lines of code to put on the base layer of the land, add the points, add the circles, add the legend. So those things, when you get up to that sort of level, do require a few more lines of code. But usually you can make a pretty decent plot within 10 or so lines of code. You can also make pretty scary plots like the one I showed earlier and the one that's going to show up next, where this is layers on layers of points in actually 3 separate plot panels. This is all those pretty basic commands that we're going to show you later. So don't be intimidated by this, but I will say this is a few hundred lines of code just with all the layers that need to be built here. But you can work your way up to this, and it's not very hard to do once you build those basic building blocks. So a few more examples of what you can do in R and some of the plots that we're going to show you and work through during the breakout rooms. There's going to be plots like this one where it's just a bar plot. Again, this is a pretty simple one, just a few lines of code. One to make the table that eventually gets fed into the bar plot function, and then one final line just to make it look pretty and draw that box around it. Another plot you can make in R pretty easily is a box plot, which you've probably seen in your statistics courses. Again, the base plot here is made with just one line of code, and then just to help with data visualization, adding that points layer on top of it. So this was, again, one that's pretty simple. And then finally, I have this to scare you all. So this is, again, a pretty simple, there's a lot of lines of code here, but this is pretty simple. What you're doing is you generate the base plot with actually no